So my project is on intermolecular and intramolecular forces, the differences between them, the different types of forces, and their attributes. So hopefully this will clear things up for any future AP Chem students. Let's get started. So intramolecular forces. The prefix intra originates from a Latin word meaning within, so it would make sense that intramolecular forces describe the forces of attraction within a compound that hold together its atoms. So an example here, an intramolecular force would be between the oxygen and the hydrogen in a water molecule, not between the water molecules themselves. Intramolecular forces cover a wide range of chemical bonds, and as a result, there are a few different types, all with varying strengths and attributes. They're also referred to in the textbook sometimes as strong forces in order to distinguish them from intermolecular forces, which are known as weak. For obvious reasons, intramolecular forces are significantly stronger than intermolecular forces. So the types of intramolecular forces. The first one we'll talk about is ionic bonding. This occurs when two atoms, usually a metal and a nonmetal, transfer electrons in order to reach a stable electron configuration. These atoms are referred to as cations and anions. You knew all that already probably. And ionic bonds are one of the strongest intramolecular forces. As a result, compounds that have ionic bonds have really high boiling points, really strong lattice energies, which pretty much just means it takes a lot of energy to break them down from their solid forms. They also conduct electricity when in solution since their atoms have a net charge. So because they gained an electron, because they lost an electron, there's a net charge, there's a potential difference, a current can form, and they will conduct electricity when in solution. An example would be table salt or calcium fluoride. Here's just what an ionic bond would look like. This is a lattice structure right here. So the next type of intramolecular force, covalent bonding. This occurs when two atoms, usually two nonmetals, share electrons in order to reach a stable electron configuration. So notice how it said share, not transfer. That's important, actually. Depending on the electronegativities between the atoms, the bond can either be polar or nonpolar covalent. So if the electronegativity difference between the two atoms is high, it'll be a polar covalent bond. If it's low, it'll be a nonpolar covalent bond. This intramolecular force is generally weaker than ionic bonding because the atoms don't form lattice crystal structures. As a result, they have lower boiling points. They won't conduct electricity when in solution. However, since their atoms did not actually give up any electrons, they don't have a net charge. So that's the reason why they won't conduct electricity in solution. They're not transferring electrons, they're sharing them. So they didn't gain or lose any net charge, so there's no potential difference, no current can form, and they won't conduct electricity. If covalent bonds do form crystals, lattice crystals, which isn't often, the crystal will be harder and stronger than any ionic or metallic crystals. So a perfect example is carbon forming diamonds. It's one of the strongest materials on Earth. So example of a nonpolar covalent bond would be H2. An example of a polar covalent bond will be H2O. Third type of intramolecular force, metallic bonding. This occurs when free or delocalized electrons are shared between a lattice of metallic ions. So that's tough to explain, and it's not really touched upon in our curriculum, but it's still important to know, I think. These bonds are usually weaker than ionic bonds, but stronger than covalent bonds. I say usually because there are a lot of exceptions. So their boiling points and lattice energies vary a lot. This type of intramolecular force yields some pretty unique characteristics. Metals that are comprised of metallic bonds are malleable and ductile, so they can be shaped and they can be formed into wire, and they will conduct electricity in their solid state. That's actually why they're used for wiring. Due to the presence of the delocalized electrons, so because of the potential difference created by the free electrons in the lattice, a current can flow. I can't really explain it better than this picture can show you how it works. And examples of atoms with metallic bonding would just be metals. So zinc and sodium are good examples. All right, so let's move on to intermolecular forces now. The prefix inter originates from a Latin word meaning between. So intermolecular forces therefore describe the forces of attraction or repulsion that exist between the neighboring particles. The types of forces that can exist between molecules and compounds are pretty diverse. Same thing with intramolecular forces, and they have varying strengths and attributes. They are significantly weaker than intramolecular force. That's really important. And they're referred to as weak forces. We already said that. So here's an example of intermolecular force. It's between the actual water molecules themselves, not between the oxygen and the hydrogen within the water molecule. So there you go. types of intermolecular forces. So the first one we'll talk about is ion dipole attraction. Ion dipole interactions occur between ionic solids and molecules with polar covalent bonds. So we'll just call those dipoles because I don't feel like saying polar covalent bonds every time. This type of force is most commonly found when ionic solids are dissolved in polar liquids. So the best example I can think of is salt and water. So the cation of the ionic solid will attract the partially negative end of the dipole, and the anion of the solid will attract the partially positive end. So here you can see that this is would be the partially positive end of the ion. This would be the partially negative end of the dipoles. The negative end of the anion, and the partially positive ends of the dipoles. So cation, partially negative, anion, partially positive. So these interactions become stronger as the charge on the ions increases, and the electronegativity difference, or the dipole moment, increases between the two atoms in the covalent bond. So put simply, the greater the charge on the ion, so +1, +2, +3, the stronger it'll be. Oh, and the greater the electronegativity difference in this bond, the stronger it'll be as well. So just keep that in mind. It's important to know. Another type of intermolecular force, hydrogen bonding. This occurs between molecules that contain highly electronegative atoms, so fluorine, oxygen, or nitrogen, that are directly bound to a hydrogen atom. The strength of a hydrogen bond increases with electronegativity difference, and the dipole of one polar molecule will align with the dipole of another polar molecule. So here's the partially negative end, here's the partially positive end, the force exists between those two, and so on to create this interaction. Hydrogen bonding increases the boiling point of the substance dramatically. For example, in water, water's boiling point is 100 degrees Celsius, but without hydrogen bonding, it'd probably evaporate in your hand. These bonds are pretty short-lived because the molecules are constantly moving, but they are very strong. They're short-lived because they have to be oriented perfectly, and since the molecules are constantly moving, it's only for a short period of time they exist. They dissipate pretty quickly, but they are strong for the time that they are made. Another type of intermolecular force, dipole-dipole attractions. This occurs between the partially positive end of a dipole and the partially negative end of another. It's pretty much the same mechanism as hydrogen bonding, but the electronegativity difference between the molecules are less, so the force is weaker in general. Remember we said the strength of a hydrogen bond is determined by the strength of a ion dipole attraction is determined by the electronegativity difference, so it would make sense that this is weaker because the electronegativity difference is less. Dipole interactions will also increase the boiling point of a substance, but just not by as much as hydrogen bonds will. The last type of intermolecular force, van der Waals, or London dispersion forces, you'll see them called as both. The forces of attraction between instantaneous dipoles in a molecule. So that might not mean anything to some of you. Pretty much instantaneous dipoles occur when electrons, which are constantly moving, are more abundant on one side of an atom than they are on the other side. So let's say when the electrons are constantly moving at any given point in time, the left side has more electrons and the right side has less electrons. So the left side would be partially negative and the right side would be partially positive. And this creates a temporary dipole. London dispersion forces are the weakest intermolecular forces, and they occur between all atoms, so not just ions, not just dipoles. They occur between every single molecule. So this is just another explanation of what I already said. Since electrons are constantly in motion, at any given point in time, the electrons of an atom could cause it to have a partially negative and a partially positive end. This creates a temporary dipole and temporary dipole-dipole interactions. This tendency to create temporary dipoles is called polarizability, and it increases with molecular size and weight. This is due to the fact that usually heavier molecules have more electrons and therefore are more likely to have electrons on one side than the other, and the electrons are also farther away from the nucleus. It's possible that a temporary dipole of one molecule causes another molecule to gain a dipole, and so on. So like almost like a domino effect. The partially negative end of one molecule can cause another molecule to have a partially positive end due to repulsion, and so on and so forth. And this is just what it looks like. So a quick summary, the differences between inter and intramolecular forces. Intramolecular forces occur between atoms of a compound, while intermolecular forces occur between the compounds or molecules themselves. So think intrastate is the highway within a state, interstate is the highway between states. Uh, Intramolecular forces are much, much stronger than intermolecular forces. The strengths of intramolecular forces are largely dependent on the transfer or sharing of electrons. So pretty much the strengths of intramolecular forces are dependent on bonding, while the strength of intermolecular forces are based on dipoles and partially negative positive ends of molecules. Uh, so I hope that helped. That's pretty much all I have to say, and thank you for listening.